From far away, every planet in the solar system looks calm, 8 dots circling the sun. But if you fell into each one of them, one by one, with nothing but a spacesuit, every single one would kill you in a completely different way. Let's start with the one closest to the sun, Mercury. Mercury is the smallest planet in the solar system and the closest one to the sun. From a distance, it looks a lot like the moon, gray and covered in craters. And just like the moon, it has almost no atmosphere. That sounds harmless, but the lack of atmosphere is exactly the problem. When you fall on Earth, the air slows you down until you reach a steady speed. On Mercury, there's nothing to slow you down. You keep accelerating the entire way until you hit the surface at full speed. A parachute wouldn't help either. There's no air to fill it. And if you somehow landed softly, a second problem would be waiting. On the day side, temperatures reach around 800 degrees Fahrenheit. On the night side, they drop to minus 290. That's the biggest temperature swing on the surface of any planet, over 1,100 degrees. And with no atmosphere, there's nothing to even it out. You're either standing in an oven or a freezer. There's no third option. Venus. Venus is often called Earth's twin because it's almost the same size with almost the same gravity. That's where the similarities end. The moment you start falling, you feel the difference. Venus's atmosphere is so thick that you don't really fall through it. You sink into it, drifting down slowly, like you're underwater. That doesn't save you. On the way down, you pass through clouds made of sulfuric acid, which starts eating through your suit. Lower down, the pressure builds. At the surface, it's 92 times stronger than on Earth, the same as being about 3,000 feet underwater. At the same time, the temperature reaches 867 degrees Fahrenheit. That makes Venus the hottest planet in the solar system, hotter even than Mercury, despite sitting nearly twice as far from the sun. The pressure crushes, the heat cooks, the acid eats, all at once. The Soviet Venera probes were built specifically for these conditions. The longest lasting one, the Venera 13, survived on the surface for about 2 hours. A human in a regular spacesuit wouldn't last a single breath. Earth. Earth should be the safe one. It's the only planet where you can breathe, where there's water, and a survivable temperature. But getting into it can still kill you. If you're falling from actual orbit, you're moving at around 17,500 miles per hour. At that speed, the air in front of you can't get out of the way fast enough. You compress it, and compressed air heats up fast. This isn't friction, it's a wall of glowing gas, and you burn in it like a meteor long before you ever see the ground. That's why every spacecraft returning from orbit has a heat shield. But if you survived that part, or started your fall from a lower altitude, the atmosphere finally starts helping you. It slows you down until you reach a steady speed of about 120 miles per hour. Still too fast to survive hitting the ground, but slow enough that a parachute could save you. Mars. Mars looks like a place you could live. A red desert, mountains, valleys, a sky. It even has an atmosphere. The problem is that the atmosphere is more than 100 times thinner than Earth's. And that's the worst possible version. If Mars had no atmosphere at all, you could slow yourself with rockets. If it had a thick one, a parachute would be enough. But Mars's thin air is too weak to stop you and too thick to ignore. Landers coming down on Mars are still racing toward the surface at over 150 miles per hour, even with a parachute open. That's why real landers use a heat shield, a parachute, and braking rockets all at once. And even if that didn't kill you, the average temperature on Mars is around minus 80 degrees Fahrenheit, and the air is 95% carbon dioxide. One breath without your helmet, and you'd be out in seconds. Jupiter. Jupiter is the largest planet in the solar system. Over 1,300 Earths could fit inside it. But it's a gas giant, so there's no surface anywhere. When you fall into Jupiter, you just keep falling. And the trouble starts before you even reach the clouds. Jupiter is wrapped in a belt of radiation so strong that you'd absorb a lethal dose while still a long way from the planet. If you survive that, you enter the atmosphere and hit winds of up to 400 miles per hour. The deeper you fall, the thicker, hotter, and darker the gas around you gets. You don't slow down, you get crushed. We know how far you can get because a probe tried it. In 1995, the Galileo probe entered Jupiter's atmosphere at nearly 107,000 miles per hour. It made it about 100 miles down and lasted just under an hour before the pressure of 22 atmospheres and the heat destroyed it. And that was still only the thin outer layer. Deeper down, the gas turns to liquid, and then to liquid metal. The core sits at around 43,000 degrees Fahrenheit, hotter than the surface of the sun. You'd be crushed and cooked long before you ever saw it. Saturn. Saturn is the second largest planet, and like Jupiter, it's a gas giant with no solid surface. It's so low in density that if there were a tub of water big enough, Saturn would float in it. That won't help you. When you fall into Saturn, the first thing you hit is its winds. Near the equator, they reach speeds of around 1,100 miles per hour, some of the fastest in the entire solar system. No suit and no spacecraft stays in one piece in something like that. If the wind doesn't tear you apart, the rest of the fall does. Up at the clouds, it's around minus 288 degrees Fahrenheit. But the lower you go, the more the pressure builds, and the thicker the gas gets, until it turns into liquid. You'd be crushed long before the core, where the temperature reaches close to 21,000 degrees Fahrenheit. Saturn has had one visitor from Earth already. In September 2017, the Cassini spacecraft, after 20 years in space, was deliberately steered into its atmosphere and burned up inside it, traveling at over 70,000 miles per hour. It was done on purpose, so it couldn't crash into one of Saturn's moons and contaminate it. You wouldn't even leave behind that much data. Uranus. Uranus is an ice giant, a different kind of planet than Jupiter or Saturn. Instead of mostly hydrogen and helium, it holds water, ammonia, and methane. It's the methane that gives it that pale blue-green color. Uranus stands out for one more thing. It's tipped over on its side. Its axis is tilted by almost 98 degrees, so the planet rolls around the sun like a ball. But the thing that would actually kill you is the cold. The upper atmosphere of Uranus drops to minus 371 degrees Fahrenheit. That's the lowest temperature ever measured in the atmosphere of any planet in the solar system, colder than Neptune, which sits much farther out. As you fall, you spend a long time dropping through that freezing gas. Then the air beneath you stops being air. There's no ground under Uranus's atmosphere. There's a mantle of hot, dense fluid made of water, ammonia, and methane, thousands of miles deep. You fall into it like hot mud you can't swim through and can't climb out of. Down there, the pressure finishes the job. Neptune. Neptune is the last planet in the solar system, and the second ice giant, very similar to Uranus. It orbits so far from the sun that a single year there lasts about 165 Earth years. From that distance, the sun is just an unusually bright star. You'd expect a place that far out to be completely calm. It's the exact opposite. Neptune has the fastest winds in the entire solar system, reaching around 1,200 miles per hour. On Earth, a wind that fast would move quicker than sound. When you fall into Neptune, you hit them right away, and it doesn't matter how strong your suit is, you're torn apart before you ever get lower. And lower down, it's the same as Uranus. No surface, just a mantle of dense fluid made of water, ammonia, and methane, the pressure rising with every mile, and a core somewhere around 12,000 degrees Fahrenheit. But inside that mantle, something stranger happens. The pressure tears methane into atoms and packs the freed carbon into crystals. Somewhere deep inside Neptune, it might literally be raining diamonds. If you'd like to see more videos like this, make sure to subscribe.